Hi folks, Mr. Long here. Ambiguous case video number 2. What I'm going to do now is to continue on from the last video and actually go through how you finish solving one of these ambiguous cases. So let's go back to where we started. So we had a side of length 30 that was opposite to an angle that was 24 degrees. There was another side that we knew in the triangle, which was 40, and we were expected to solve the triangle. So let's look at that picture again. So the picture looks like this. Okay, so that's what our picture looks like. The opposite side to A is 30. Another side is 40. And we always, personally, I always orientate my triangles this way. Whatever the letters are, A, B, C, D, E, F, I take the given angle, an opposite pair, and put them across from each other just like this. And then I always put that second side right there. Okay, the second side goes adjacent to the A. So this is the scenario of side-side angle, because remember, the angle right there is 30 degrees, right? That's a 30-degree angle at A. Or sorry, a 24-degree angle at A, because that information is right here. Okay, so we went through the process last time where we substituted everything into the cosine law, and we ended up with a quadratic equation. And we could use the quadratic formula. Of course, once you get this formula right here, oh my goodness, excuse me, I just yawned. Sorry. Once you get this quadratic equation, you can then input that into your polysolve on your black calculator to get your answers. But again, you do have to know how to use the quadratic formula, but you would get those two answers. Okay, so this is for the bigger triangle, and this is for the smaller triangle. Now there's a lot more work to do, though, because the question isn't just solve for that side, it's to solve the triangle. So here's what we need to do. We need to figure out all the angles in the triangle. Let's start with the bigger triangle, okay? I always call the bigger triangle, triangle number 1. So let's go back over here to this one. And what I'm going to do is just draw out that triangle again so you can see the smaller triangle. And so here's what we'll do there is take that smaller triangle. So the smaller triangle is going to look like this, right? So we can take that and move that out. So that's what the smaller triangle looks like. And I'm going to remove that. And I'm going to take this C prime. Well, I'll leave the C prime there for now. But that's what our second triangle looks like. So our first triangle looks like that. And this is our second triangle, okay? And again, this is still A. This is C over here, and that's B down there. So our second triangle is the triangle that fits right in there, okay? All right, so let's go back to our first triangle. So we know angle A is 24 degrees. So it's time we need to find out angle B and angle C. So how are we going to do that? Well, with our cosine law. Okay, so in this case, I want to find out, I'm going to start by finding out angle C. I want to find out angle C. And I could have picked C or B, it doesn't matter. I'm going to pick C first. So I'm going to write the cosine law for angle C. So we know that side C is opposite angle C. So that's why we write it this way. So it's going to be C squared is A squared plus B squared minus 2AB cosine C. Oh, whoops, there shouldn't be an equal sign there. Okay, so it's going to be, I'm going to substitute in my known values. C is 40. That was given. A is 30. That was given. We figured out B as 61.7 with the quadratic formula, minus 2 times 30 times 61.7 times cos of C. So just like we did a few days ago, we went through some algebra and we isolated for cos C like this, and then we evaluate that and do cos inverse or just apply cos inverse to this formula right here. Okay, so I'm not showing some of those steps, but I think you know how to do that. C works out to 32.8 degrees. And so C is 32.8 degrees. And it was given that A is 24 degrees. Well, we know the interior angles of a triangle add up to 180. So I can take 180 minus 32.8 minus 24, and I get angle B having a value of 123.2 degrees. Okay, and so what I've done is summarized all those values in this table right here. Okay, I've summarized all those values. All right, so in this case, you're not done yet. Okay, this was kind of awful, but what you have to do in this case now is you've got a whole other triangle to work with. And in this case, side B was 11.3, so it was much smaller. So let's go back and look at that smaller triangle, right? So the smaller triangle, this side was still 40. This side was still 30. Okay, so I'm looking at this right here. So this side is still 30. This side is still 40. This angle is still 24 degrees. Okay, but we need to figure out, B is at the bottom, so I still need to figure out angle B, and I need to figure out angle C. Oh, by the way, that distance is 11.3, right? We figured that out to be 11.3. So let's go back to our calculations. So same thing, I rewrite the cosine law. C squared is A squared plus B squared minus 2AC cos B. Hopefully I did that correctly up here too. Oh no, I've got a mistake there, don't I? That should be a B there. Actually, there's a few mistakes in there, isn't there? That should be C because we're trying to figure out C. Yeah, okay, good. So I see. I had my apologies, folks. I had a B earlier and I had to change it. So all of these should have been C. There we go. Okay. So once again, we just substitute into that cosine law for A, B, and C. And what's really, really important here is that you would have drawn a picture of those two triangles, right? Because if you're looking at the equation without looking at the triangle, you can't make any connections at all. It's very difficult to do. And I really think, again, you should work through this problem in its entirety. So we figured out angle C, which is 147.2. And then, again, work backwards from 180. So 147.2, 24, and then that leaves us, when we subtract from 180, 8.8 degrees. Okay, so that's a pretty odd looking triangle. And then that's our summary there. So let's go back and look and see if angle B makes sense to be only 8.8 degrees. Well, I'm going to take this and bring it up to here, and so you can see, if you look at it, angle B is going to be a pretty small angle, right? So if you look right there, angle B is this tiny little angle here. So that's 8.8 degrees. So that does make sense, right? That does make sense. Okay, so folks, that's the whole process from start to finish to do one of these where you figure out all the angles, all the side lengths for both triangles.